Today we will be discussing Pythagorean triples and the converse of the Pythagorean theorem. You previously learned that when two sides of a right triangle are known, the third side can be found by using the Pythagorean theorem. We learned this yesterday. And let's just recall that Pythagorean theorem is a squared plus b squared equals c squared. Any group of the three positive integers a, b, and c such that c squared is equal to a squared or b plus b squared is known as a Pythagorean triple. This is important because any factor of this is also known as a Pythagorean triple. So let's take a closer look at what they may be. Example 1 says, is 3, 4, 5 a Pythagorean triple? Remember, we know that 3 and 4 are small sides, so those are our a and b, and c is our longest side. So if we use that knowledge, we can see if a squared plus b squared is equal to c squared. So we'll say that 3 is a, 4 is b, and 5 is c. So 3 squared plus 4 squared. We want to know, does it equal 5 squared? 3 squared is 9, plus 4 squared, which is 16, is equal to 5 squared, which is 25. 9 plus 16 is 25, and 25 does equal 25. So yes, this is a Pythagorean triple. So now we need to name a few other Pythagorean triples. The first one we learned about was a 3, 4, 5 right triangle. So we have a 3, 4, 5. You also have one that is a 5, 12, 13, an 8, 15, 17, and a 7, 24, 25 Pythagorean triple. So all of these, if you know you have one side which is 3, one side that's 4, the other side's going to be 5. A key thing to remember, any factor of these is also a Pythagorean triple. So if I multiplied the 3, 4, 5 triangle each by 2, we'd have a 6, 8, 10. Or if you multiplied by 3, you'd have a 9, 12, 15. All of those are still Pythagorean triples as well. If you recall that given 3 sides, a triangle can be formed only if the sum of the smaller 2 sides must be greater than the third side. So in an inequality that looks like this, a plus b is greater than c. So let's determine if we can have triangles based on the side lengths. In example 2, it says which of the following can be lengths of a triangle. We're going to look at each part of the example and determine if each one of the side lengths given can make a triangle. Remember, you have to add the first 2, or the smallest sides, and compare it to the larger side. So we'll add 4 plus 5 and say, how does it compare to 6? 4 plus 5 is 9, so it is greater than 6. So this triangle, or this set of sides, can form a triangle. What about 4, 5, and 9? 4 plus 5, how does it compare to 9? 4 plus 5 is 9, and that is equal to 9. So this set of sides cannot form a triangle. And C, we have 4 plus 5. How does it compare to 10? 4 plus 5 is 9. That's less than 10. So this one can't produce a triangle as well. We can take this a step further, because if you remember, one way to classify triangles is by its angles. A triangle can be acute, obtuse, or right. If a triangle can be formed, you can determine the type of triangle formed by comparing the squares of the longest side, which is C, to the sum of the squares of the shorter side. So once we've compared the two smaller sides to the larger side, we can flip, square, and add to determine what type of triangle can be formed with the side lengths that we have. A right triangle can be formed when C squared is equal to A squared. That is our Pythagorean theorem. An acute triangle can be formed when C squared is less than A squared plus B squared. And an obtuse triangle can be formed when C squared is greater than A squared plus B squared. Let's look at a few of these examples. First, example 8 says to determine if a triangle can be formed, and if so, to classify it. We have the sides 5, 12, and 4. The first thing you want to do is put the sides in order from least to greatest. We have 4, 5, and 12. Next, we must add the two smaller sides together and see how do they compare to the larger side. We add 4 and 5, so 4 plus 5, and we say how does that compare to 12? 4 plus 5 is 9, so that's less than 12. Remember, the two smaller sides must be greater than the third side to be able to form a right triangle, or to form any triangle. So no, a triangle cannot be formed. Let's look at another example. We have the sides 6, 7, and 8. 6 plus 7, how does that compare to 8? 6 plus 7 is 13. That is greater than 8. So yes, we can form a triangle. Now we need to know what type of triangle we can form. This is where we will flip, square, and add the side lengths. By flip, we mean to go from largest to smallest. So we will say 8 squared. How does that compare with 7 squared plus 6 squared? 8 squared is 64. 7 squared is 49. Plus 6 squared, which is 36. 49 plus 36 is 85. So how does 64 compare with 85? It's less than 85. From our rules earlier, if C squared is less than A squared plus B squared, we have an acute triangle. Let's look at another example. 1, 3, and the square root of 10. First, we add the two smaller sides. 1 plus 3. How does that compare to the square root of 10? 1 plus 3 is 4. The square root of 10, if we put it in our calculator, is 3.162 rounded. 4 is greater than that number. So yes, we can have a triangle formed. The calculator can be used to help us figure that out, which is greater. Now we have to flip, square, and add. So start from largest to smallest. The square root of 10 squared. How does that compare with 3 squared plus 1 squared? The square root of 10 squared is 10. Remember, the square root symbol and the squared will cancel each other out. So 10, how does that compare with 9 plus 1? Well, 9 plus 1 is 10, so we have 10 is equal to 10. So we had c squared is equal to a squared plus b squared. So what kind of triangle do we have? We have a right triangle. And let's look at one. Determine if a triangle can be formed, and if so, classify it. We have the square root of 9, the square root of 16, and the square root of 27. So we need to add the two smallest numbers, the square root of 9 plus the square root of 16, and see how does that compare with the square root of 27. The square root of 9 is 3. The square root of 16 is 4. How does that compare to the square root of 27? Again, I typed this into the calculator and found that the square root of 27, rounded, is 5.196. So how does that compare? 3 plus 4 is 7. 7 is greater than 5.196. So yes, a triangle can be formed. Now let's determine what type of triangle can be formed. Remember, we have to flip, square, and add from largest to smallest. So we have the square root of 27 all squared. And we want to know, how does it compare to the square root of 9 squared plus the square root of 16 squared. Sorry, I ran over into the other part. Well, the square root of 27 squared, again, remember the square root and the squared cancel each other. So we have 27. How does that compare to the square root of 9 squared, or 9, plus the square root of 16 squared, or 16? We have 27, comparing it to 25. 27 is greater than 25. So from our rules, we have an obtuse triangle. If you have any questions, please be sure to ask. And if you have any questions when you're not at school or where you can get a hold of me, please send me an email and I'll get back with you as soon as possible.